Hi, this is the reading for Chapter 2, Lesson 1, Properties of Minerals. What is a mineral? Look at two substances in this figure 1, which is on the next page. On the left is a hard chunk of coal. On the right are beautiful quartz crystals. But both are solid materials that form beneath Earth's surface. I asterisked the beneath Earth's surface. But which one is a mineral? So we're going to compare those two. Defining minerals. How are minerals defined? A mineral is a naturally occurring solid, so it has to be solid, that can be formed by inorganic process, I'll explain that in a minute, and has a crystal structure with a definite chemical composition. Lots of things involved. We'll break all that down for you. For a substance to be a mineral, it must have all 5 characteristics. So is either quartz or coal a mineral? It's beneath Earth's surface. It has to be a solid, inorganic, crystal structure, definite chemical composition. And we move to this page. It is naturally occurring. All minerals and substances that are formed by natural process. Quartz is formed by a natural process as molten material called magma cools and hardens beneath the earth. But coal forms naturally from remains of plants and animals that are squeezed tightly together. So they're both naturally occurring. A solid, a mineral is always a solid with a definite volume and shape. Particles that make up a solid are packed together tightly, and they compare that to a liquid. Liquids can move around in a container. A solid cannot move around in its shape. Coal and quartz are both solids, so we marked them over here. They're both naturally occurring. They're both solids. Crystal structure. The particles of a mineral, they line up in a pattern that repeats over and over again. The repeating pattern of minerals particles form a solid called a crystal. So if I was to drop this and break this crystal, all of the crystals would break into the exact same shape. That's how they formed. It's just a repeating pattern. A crystal has flat sides called faces, like we learned in math, that meet at sharp edges and corners. In quartz, in this figure 1, it has a crystal structure. In contrast, coal lacks crystal structure. So we put an X for coal and a check for quartz. Forms by inorganic processes, which means non-living things. All minerals must be able to form by non-living inorganic things. Every mineral must be able to form from minerals that are not part of living things. Quartz can form from magma, that's not living, but coal forms from living things. So guess what? Coal is not inorganic. Quartz forms naturally by magma. Coal comes from living things. Sorry about repeating that. Definite chemical composition. We talked about an Oreo and a Chips Ahoy cookie again. They have different ingredients, which make them different cookies. So just like in rocks and minerals, the different ingredients make them different minerals. A mineral has a definite chemical composition. That means that a mineral always contains certain elements in a definite proportion. An element is a substance composed of a single kind of atom. So that gets a little bit into chemistry, but the ingredients that are inside have to always be same. Like we have H2O, it will always be water, but it always has to be H2O. And carbon dioxide is carbon and 2 oxygen together, and it will always be carbon dioxide if you have that combination. The elements in coal can vary over a wide range, so theirs kind of change a little bit. Page 52. Minerals, compounds, and elements. Almost all minerals are compounds. Think of chocolate milk. In a compound, 2 or more elements are combined so that the elements no longer have distinct properties. They talk about cinnabar. I'm going to skip that part. They're just saying that sulfur is yellow and mercury is silver, but when combined, they have a shiny red crystals. Different minerals have different combinations of elements. For example, a crystal of quartz has 1 atom of silicon for every 2 oxygen. This ratio will always be the same. This ratio is consistent for all varieties of quartz. Each mineral in a garnet group has 3 atoms of silicon for every 12 atoms of oxygen, but garnets can look different colors. I use the example of that is garnet, it's very dark, and the garnet on my ring is more red. So whatever elements are in the garnet can vary to change the color. Some elements occur in nature in a pure form and not as a part of a compound. Elements such as copper, silver, and gold are also minerals. Almost all pure solid elements are minerals. We actually looked in our agenda at our periodic table, and we looked it up online also. If you want to do that, you can look for all the metals, how they separate the elements in the periodic table. We enjoyed that little activity. We will move to page 53. Just kidding, this is 54. This is 53. How are minerals identified? Geologists have identified more than 40,000 minerals, but telling these apart can often be a challenge. Each mineral has characteristic properties that we use. We identify them by color, by streak, by luster. Color, both minerals here are gold, but only one is the mineral gold. This is pyrite, which is pirate's gold, so that's fake gold. And this is actual gold. Streak. A streak of a mineral is a color of its powder. So if you get a rock and you scratch it on the sidewalk, you can identify it by its streak. However, streak color and mineral color are often different. So you can compare that. This looks brown, but it comes out as a burgundy color. This is very bright green, but it comes out kind of as a dull green. For example, pyrite has a gold color, but when you streak it, it's a greenish black. Luster refers to how light is reflected. This is not shiny. This is waxy looking, and this is like a metallic. So we can identify them by their luster or how they reflect light. And then page 54, hardness. When you want to identify a mineral, we use the Mohs hardness scale. It goes from 1 to 10, and we line them up. If you ever had talc, you can actually peel it off. It's thinner and softer than your fingernail. It just comes off in little sheets. And then as you go higher with these minerals, they become harder. You could get some rocks and you could scratch them on your fingernail. And if they're harder than your fingernail, they'll scratch your fingernail away. And then, so as you go forward, as the rock is harder, nothing can scratch it. But diamond is extremely hard. It can scratch all known common minerals. Diamonds are the hardest. So you can do a scratch test when you're out on the sidewalk with some rocks that you find. Density we talked about. Density is mass divided by volume. Mass is like the weight of an object, and the volume is the space that it takes up. So pretend I have a rock that's like 0.5 ounces, and then I drop it in the water, and then it takes up like 0.1 liter. So I would divide my mass, my weight, by my volume, and then I would get its density. We kind of talked about if I was to hold a golf ball or a ping pong ball, which is hollow with an egg, I can kind of go like this and I can see which one is heavier. You can do that with two rocks too of the same shape. See if one's heavier than the other one. Even though they're the same shape and size, one might be more solid or more dense. And then we're going to stop there. Tomorrow's lesson, we'll continue reading the chapter.